Hi, everybody. Welcome. We're just going to give it another minute or so as participants continue to dial in, so stick with us. All right, I think the numbers have started to slow down on the ticking in, so we're going to get started. Welcome, everyone. Thank you for joining us this afternoon or this morning, depending on where you are. I'm Sarah Mason. I'm the Deputy Executive Director of Clean Energy for America. I'm excited to bring this briefing to you all on how we can decarbonize the aviation industry. Personally, I'm about to get on a plane tomorrow, kicking off that summer travel season. So very excited to hear about the future of this industry and how we can make it cleaner. So I'm joined today by our moderator, Maria Martinez, Breakthrough Energy, Jason Salfi, the CEO of Dimensional Energy, Alex Minotti of LanzaJet, and Todd Solomon of ZeroAvia. We're so excited. Thank you to all of these awesome experts. And with that, I am going to turn it over to Maria.
Thanks, Sarah, and thanks everyone for joining us. It's a really exciting topic and very right on the money with summer travel season starting. You're right. My name is Maria Martinez. As Sarah mentioned, I'm a Director of Policy and Advocacy at Breakthrough Energy. For those of you that don't know us, Breakthrough Energy is a network of philanthropic investment and policy initiatives launched by Bill Gates in 2015, focused on achieving a net zero economy by mid-century and accelerating the pace and scale of innovation to get us there. Before we turn it over to this great set of panelists, I wanted to set the scene very briefly on this important sector and why we need to work very aggressively to decarbonize it. For those of you that aren't super familiar with aviation, it accounts for approximately 3% of global emissions today. It doesn't sound like a ton, but it's likely to double in the next 2 decades, given the increase in passenger travel and other demand surge. Aviation is a particularly tough puzzle because the energy density required to power these aircraft is extremely high. And you also need to be able to lug around your energy with you wherever you go. And safety requirements are, of course, the utmost priority because flying humans in a metal tube in the middle of the air leaves no room for error. So the regulatory landscape is especially rigid for new market entrants. And typically when we think about reducing emissions in aviation, there are a couple of sort of tools to do that. One is reducing demand, which is very challenging because the whole world wants to and sort of deserves to get around, get to see new places, visit family and friends. We saw that, post-COVID surge. So reducing demand is sort of one instrument that is particularly challenging. Another thing that we can think about when we're saying, reducing emissions of aviation is improving the fuel efficiency and the design of engines to basically go further with less fuel. That's another option. We also have the option of deploying clean jet fuels to replace the existing sort of fossil fuel based kerosene that powers most aviation today, especially long haul travel that is especially requiring that energy density I was mentioning. And the last category of things we tend to think about is new propulsion technologies, sort of new ways to get around that require either electrons and hydrogen or some other source of energy to move the jet. So those are the main levers we think about. Today, we're really going to focus on those last two, alternative jet fuels and new propulsion technologies, progress being made in that space, what the implications of the new policy landscape and all of the initiatives and incentives we saw coming through in the Inflation Reduction Act, some of the administration's initiatives like the SAF Grand Challenge, the Department of Energy's Earthshot goal on clean jet fuels, and also learn a little bit more about the remaining barriers to seeing these technologies take hold in the market at a large scale. And as a very brief appetizer for those of you that aren't well versed in the lingo, when we say clean jet fuels, we're typically talking about something called SAF, sustainable aviation fuels, which could be made via biological processes using things like woody debris from forest thinning, municipal solid waste, and even things like French fry grease. And we're also talking about non-biological ways to do it, essentially using the power of electricity and waste carbon and hydrogen to make molecules that are chemically identical to what powers airplanes today. So those are sort of SAF technologies. And then when we say new propulsion technologies, we're really talking about things like electric aircraft and hydrogen electric aircraft and other ways to power these engines, using batteries and other fuel cells, other ways of doing this. And so we'll learn a little bit about all of those things today. We have a great lineup of companies representing the breadth of these technologies. And so I just wanted to make sure everyone operates with that baseline knowledge, because the world of climate and energy is full of a bunch of acronyms. So I'll leave it at that for the introduction. But first things first, would love all of the panelists to give your sort of elevator pitch version of what your technology is and why it's so important to decarbonize aviation. And just since everyone's popping up on my screen, Jason, maybe I'll start with you.
Thank you very much for the introduction to this really big topic. Welcome, everybody. So my name is Jason Salfi, co-founder and CEO of Dimensional Energy. We transform carbon dioxide into sustainable aviation fuel and various products. Our technology really is about defossilizing the supply chain for these renewable hydrocarbons. And we've come up with a novel technology to think of it as cutting that carbon dioxide molecule in half so that we can use that carbon as a source for hydrocarbons, and then using renewable hydrogen as the hydrogen source for the other part of the hydrocarbon fuels. Our company is focused on first addressing the really difficult to decarbonize sectors of our economy to source our CO2. And over time, we envision a world in which CO2 becomes more abundant and ubiquitously available. But right now, what we're seeing is a tremendous opportunity to use point source carbon emissions before it actually enters the atmosphere, so that we don't have to do it when it's so dilute. We feel like this is a great first step to help decarbonize one sector of an economy while complementing another with a ideally more renewable fuel source. And I'll just leave it there and pass it to I'll popcorn over to Alex.
Okay, well, thank you very much, Jason. We'll stay with SAF before moving over to hydrogen. So I'm Alex Minotti, VP of Government Affairs, Policy and Sustainability at LanzaJet. We are an alcohol-to-jet sustainable aviation fuel company. So we take low carbon ethanol and convert that into drop-in sustainable aviation fuel. We were spun out of LanzaTech in 3 years ago, just actually yesterday, just had a press release today about this. LanzaTech developed with the technology originally developed by the Pacific Northwest National Laboratory at DOE for this alcohol-to-jet technology, demonstrated flights in 2018 and 2019, and then stood us up as an independent company with some other investors, including Shell, Suncor, a Canadian oil company, Mitsui, and British Airways, as well as LanzaTech, of course, to help commercialize this technology. And we're building our first plant in Soperton, Georgia, 10 million gallons a year, under construction today, using low carbon ethanol to SAF. And so I think we can get into further in the panel the discussions about SAF generally and why SAF is needed, but in terms of our technology, alcohol-to-jet technology, there's a lot of advantages to it in terms of producing a significant portion of the SAF that we're going to need to decarbonize by 2050. So I'll start with in terms of ethanol is a widely available molecule, both with existing capacity today, 17 billion gallons of U.S. ethanol, a lot of Brazilian ethanol as well. and something that we can move around very easily. That's a great building block for SAF, but we can also make ethanol out of a lot of other things as well, whether that be cellulosics, municipal solid waste, MSW, and LanzaTech, our investor company, is pursuing a lot of those technologies. Anything we can gasify, we can turn that into including captured carbon. With hydrogen, we can turn that into ethanol and then upgrade that into sustainable aviation fuel. So in terms of building out this industry quickly, a huge opportunity with alcohol to jet to use that existing resource and catalyze a new ethanol resource as well. And that 17 billion gallons of US ethanol that we have today, with light duty electrification is likely going to be looking for a home. And we can turn that into 11 billion gallons of more energy dense sustainable aviation fuel. So that's over 50% of US aviation demand today if we just put our biofuel in the right place, in those hard to decarbonize sectors that need that biofuel. Second, for alcohol to jet, I would say that we think we have a very attractive technology in terms of the yield of SAF that you get when you make, when you do your conversion process. There's 7 different SAF approved pathways today, and some co-processing pathways with ASTM. Jason will discuss one of those, the Fischer-Tropsch process, and there's also the existing process called hydrotreating esters and fatty acids. But alcohol to jet is very much geared towards sustainable aviation fuel, as our name suggests. So we can make 90% sustainable aviation fuel, 10% renewable diesel, or we can turn that dial without additional CapEx or operational costs and make 75% diesel and 25% jet. So some real advantages of what we're looking for is SAF. Don't have a lot of additional co-products unless the market is dictating us to go and turn that dial to make more diesel. And then finally, we think it's quite an efficient process as well. 99% of that carbon in that ethanol will end up in your final fuel products as well, and we can do this conversion for an attractive carbon intensity process there in terms of the number of the life cycle emissions reduction that we can achieve with alcohol to jet of 70% or more, depending on that technology. So I'll pause there, but lots more to say on alcohol to jet. Thank you.
All right, I guess it's my turn. Yeah, I think y'all are in for a bit of a chemistry lesson today. Just thinking of what we're hearing already. I'm Todd Solomon. I work on U.S. government affairs and policy for ZeroAvia. We are developing hydrogen electric powertrains for aircraft. And we are going to take those powertrains and retrofit existing airframes. So, aircraft are they last like 30 years plus. So we think we can get in before those aircraft expire and give them a useful zero emission rest of life. The way it works is we have a fuel cell, which allows hydrogen and oxygen to do kind of a drive-by, and proton from hydrogen passes through a membrane, but the electron is captured as direct current. That current passes through an inverter, where it's transformed into AC or alternating current, and that powers an electric motor. And then the electric motor through a gearbox turns a propeller or a jet fan. So it's kind of basic high school chemistry, sort of juiced up. But each of those phases, the fuel cell, the inverter, which we call power electronics, and the motor, they allow us to engineer variables that can impact the power and efficiency. So we have our sights set, like the sort of distant prize is the narrow body jets that you fly on, like Boeing 737s or the Airbus A320. Those aircraft currently produce 50% of aviation's greenhouse gas emissions. So to get there, we're not starting with those big planes. We're starting with turboprop aircraft. We have a 9 to 19 seat powertrain that has already been flight tested. That will be our launch model, and we expect to be in service in 2025 with that. We have an 80-seat model, twin turboprop aircraft, ready probably in 2027. And then regional jets in 2029. So regional jets would be like a CRJ 700. If you've flown regional, you've probably flown on an Embraer 175. Those are the aircraft that have like 2 and 2 seats across. And then these narrow body jets in 2032. That's a pretty ambitious target. But in every segment that we've modeled so far, the operating costs are significantly lower than flights powered by jet fuel. So it's not just a question of clean, it's a question of lower operating costs. And when you talk to the airlines that have already we already have purchase agreements with, like United and American and Alaska, they will tell you that it's awesome to be able to check the box of clean aviation, but the economics are also really a selling point. And we are also looking to start manufacturing. So we have facilities in the UK. We started R&D in California, but we wanted to really get advanced. It turned out that the funding availability was much greater in the UK, and I think we'll have a conversation about that if we can today. We have the larger aircraft the powertrains are being worked on in Everett, Washington, north of Seattle, and some of the fuel cell work is also being done in the UK. So in Seattle, we're excited. In Everett, we have a Dash 8 Q400 that we're retrofitting now with a 2 to 5 megawatt motor. And when we fly that, it will be the largest aircraft to fly with hydrogen. You should know that there's another, we have competition. So we're not the only players in this field. Someone flew a Q300 last month, a company called Universal Hydrogen. And it's exciting because we have competition, and larger airframe manufacturers are working on this stuff. Larger engine companies are working on this stuff. So it's a bit of a race.
Thanks so much, Todd. And thanks, Jason and Alex, for giving us a brief and somewhat simple chemistry lesson. I think the takeaway for all of you that are not chemist enthusiasts is that there's a lot of really cool innovation happening. And I think the size of the problem in aviation is so large that there is room and a need for all of these technologies. We have long haul travel, cross Atlantic that is very dependent on energy density. Meanwhile, we have sort of short haul and new forms of commerce. Maybe in the future, we have autonomous planes delivering organs for us and other things. So there's a lot of really cool innovation happening in the aviation space where there's room for all of these technologies to play a huge role in cleaning it up. So for the audience, please start thinking of your questions and please drop them in the chat. We will, in a moment, turn to audience questions. But I did want to start with some beefy ones for all of you on getting into the weeds of the challenges and the opportunities here. And the first one is diving right in. Let's talk about financing projects, because all of you are trying to do something very, very new, and it requires novel feedstocks and inputs that on their own have risks. It requires securing loans and other finance from traditional commercial providers that sort of have their own challenges with overcoming the risk inherent to newer technology. But that doesn't mean it's impossible. And would love to learn from you all as you're building projects and taking on these new efforts. What are those types of challenges? How are public investments and policy support helping bring that risk down? And how can we think about the sort of opportunities on the horizon with these new tax credits from the Inflation Reduction Act, new programs like the Loan Programs Office at the Department of Energy, instruments that exist like low carbon fuel standards, research and development grants? Like what role does it play in helping de-risk these technologies to help build them? So I'll switch it up and say maybe Alex, if you're willing to start on this one, and then we'll popcorner around again.
Sure, and so with popcorn, I'm responsible for handing off, I assume. Okay, somewhat new term for me. So this is a very, very relevant topic for us. Thank you, Maria. We are building our first facility, and proud to say that it is it is fully financed. And so this is not only a new industry with technology risks and first of a kind projects, but this is also a relatively high CapEx industry as well. We have to build new facilities. We have to put steel in the ground. So there are certainly challenges, and I think that what we've learned in financing our facility is it really requires partnerships. No one can do this alone. What you hear in a lot of these conference circuits for SAF is that the need for a long-term offtake agreement. I think that is necessary, but certainly not sufficient to finance these facilities. So we took a really unique approach with both public and private assistance. First, of course, all the work that was done by FAA and others to develop this technology and support the ASTM approval, DOE developing this technology, very, very critical. But we also had a DOE grant to help us with engineering work and initially helping to build this facility. Our investors and partners have all contributed to this, of course, but certainly other gaps to fill. Access to low cost capital, really critical. We're really thankful to Microsoft for offering us a $50 million loan, the loan component of our financing at very low competitive rates that we might not otherwise be able to get to leverage their balance sheet. In terms of assisting with CapEx. Very thankful for Breakthrough Energy Catalyst to provide us, and thank you, Maria, to Breakthrough Energy for that, to provide the first loan, grant from that program for sustainable aviation fuel. So $50 million to help buy down that CapEx has allowed us to move a lot quicker and provide a much more affordable product in the end, and move faster on that second, third, and fourth facility. So this is probably sort of unique financing that you'll see on the first facility, but there's definitely a role for policy to play in those until we get to that nth facility and really the second through eighth or so facilities. Really critical to have continued policy support. You mentioned some of those things like the Loan Programs Office. We're very excited about the new grant program at FAA, the Fast SAF grant program that was included in the IRA, $250 million for SAF grants, hoping to see more of that in the FAA reauthorization. Of course, there's existing programs under DOE for industrial decarbonization and otherwise that could be appropriate for SAF. We just saw the 48C credit guidance with SAF, as a priority just yesterday. But the critical underpinning, the foundation for our industry in terms of financing these facilities is those IRA tax credits for sustainable aviation fuel, specifically the output of this facility. And so we have the new SAF blenders tax credit under the IRA, $1.25 to $1.75 a gallon, performance-based, technology feedstock neutral, transitioning into the 45Z tax credit that also has a premium value for SAF as well, in recognition of the nascent state of this industry and the need to really build this out quickly. I would say that we do need long-term policies, and that's one thing to continue to work on with the IRA. The SAF BTC is only 2 years, 23 and 24, with the 45Z credit being 3 years. We really be critical to extend those out. The facilities that we're designing today, the next facilities might not be in operation until 2026, 27, that time frame when those tax credits are expiring. So it'd be really critical to have long-term certainty like we have with a lot of the other IRA tax credits, and that's one of the focuses of LanzaJet in the sustainable aviation fuel industry to get at least 10 years of certainty on those tax credits. I will pass it off to Todd.
All right.
Thank you.
Thank you.
Sorry, I forgot about the popcorning. Yes.
Sure.
For you, Alex.
Yeah, this is, this is really the big question. I think we all have such faith in our technology that it's really just a question of how we get there, how we pay our way there, right? So we also have an application in with the LPO to get our manufacturing going. And credit programs like that are a huge opportunity. I worked at DOT for many years, and the TIFIA program there really plays a good role. There's current legislation for a hydrogen infrastructure credit program. It's sponsored by Senators Coons and Cornyn. And we would like to see something like that. It would really help airports, for example, apply into such a program and to finance projects that will help them meet their airline customers' needs, right? The tax credits in the IRA, 48C for clean energy manufacturing, 45V for clean hydrogen production, are going to be awesome. Tremendous boost, I think, for us. But the FAA has an upcoming reauthorization that's going through Congress now, being drafted by the committees. And there's an opportunity there to create credits, tax credits to operators and carriers for purchase and deployment of clean tech as well, so that they have a greater incentive to jump in and retrofit their aircraft sooner rather than later. So those programs are great. But it's worth pointing out in the R&D side that between 2013 and 2019, the sort of last pre-pandemic year, the average CO2 emissions per revenue passenger mile, which is how we sort of measure efficiency, improved by 12% over that time. But the number of revenue passenger miles increased by 50%. So all these sort of efficiency gains are getting completely erased by traffic gains, right? Air traffic is growing 4 times faster than we can improve efficiency. So whatever efficiency gains we've been financing with taxpayer dollars are not keeping up, right? So we need, at least at ZeroAvia, I think we need something that isn't just nibbling at the edges, right? I'm thinking specifically of the FAA Clean program. There's a NASA Sustainable Flight National Partnership that also works a lot on efficiency. And I think those programs need to really start seeking a step change. I think, and Alex mentioned the FAA Fast SAF program. So I think that's going to be a huge boost as well. Just want to point out, there's two, right? There's a Fast SAF and a Fast Tech program. The Fast SAF program got $250 million from Congress in the IRA, and all the other propulsion ideas combined got $46 million. So obviously for a company like us that's working on hydrogen, we'd like to see a little balance there. It has the scent of the government picking winners and losers, right? Which isn't necessarily what we want. Nobody in ZeroAvia has a beef with SAF. Let's make that clear, right? I think all of us would agree we need the all of the above approach. There's a tremendous benefit to SAF and alternative fuels because you can drop them in, right? So it can happen much faster. But in addition, I would say we need a NASA and a DOE that lend their expertise to the FAA, which has been struggling a little bit. We need a DOE that opens its hydrogen fuel cell technology office to aviation and not just trucking. And we need an FAA that opens its R&D portfolio to alternative propulsion. So the challenge for us has been to get a seat at the table, which I think we've been scrappy enough to achieve. Getting the attention of a very busy Congress for this FAA reauth has been a challenge as well. But it's such a big opportunity. If you don't follow it, it's a 5-year bill that sort of guides the FAA's priorities. Give an example of how important it is. The last authorization for the FAA sort of ignored the eVTOL community, and the FAA is getting slammed by eVTOL, requests for certification because this industry came up rather fast, and I think all of us believe that our sector of this industry is going to come up super fast as well. So this reauth is really a big chance. There have been some great signs. So Congressman Lucas, who chairs the House Science Committee, introduced an FAA R&D title last week or 2 weeks ago, maybe, which includes explicit direction to the FAA to begin considering hydrogen, how to integrate hydrogen power. Congresswoman Del Bene introduced a bill in April that would expand the, there's a joint DOE-DOT Office for Electric Vehicle Charging, and it would expand that to sort of include all of sustainable aviation, all of sustainable transportation, excuse me. Last year, Georgia Senator Warnock had an H2 Aero bill that got adopted into the Inflation Reduction Act, those tax credits. Some of that came from that bill. And this year, Georgia's other senator, John Ossoff, is also going to introduce a bill supporting hydrogen aviation. So we think it's a pretty promising outlook, but there's a lot of policy needs that have to be met. And I will hand it over to Jason.
Excuse me, getting over a cold. Thank you, Todd. Yeah, and so I think just to segue a little bit, off of what you said and leverage some of your hydrogen space here, we too would benefit greatly from a 45Z, right? So we are using renewable hydrogen as part of our chemistry here. And one of the things that we're looking at, not to kind of rehash all the other numbers and letter codes that Alex went over, but is we look at, so our projects comprise many different facets of the new incentives that are out there. And so being able to stack a 45Z, Q, and V would be a fabulous win for our feedstocks and our sort of inputs, not to mention say the renewable energy side, on the production side. So to synergistically work with renewable energy developers, where we're all benefiting, perhaps under less entities that need to say pass over the fence the different molecules and electrons to make the e-fuels, but actually just assemble one entity that can perhaps stack all. And certainly buy side credits are helpful as well. It helps us just say level the playing field between our customer base and our sort of whole supply chain. And so just to give you a little bit of an overview more about dimensional energy and our trajectory right now. So we look at things from the ground up. So it's not only the feedstocks and the molecules we use to assemble the SAF, and it's also from a impact side and a workforce development side. So we operate in 3 locations right now. We have a catalyst manufacturing facility in Ithaca, New York. We have a pilot that runs 24 hours a day. It's our Technology Excellence and Workforce Development Center in Tucson, Arizona. It runs 24 hours a day, producing renewable synthetic crude from carbon dioxide and water. And we have an engineering office in Houston. So we're a fast growing team of over 30 at this point, with projects coming down the pike, starting with a Lafarge Canada plant in Richmond, BC, where we're doing a point source demonstration of 1 ton per day of CO2 to sustainable aviation fuels and products. Savante is our carbon capture partner up there, and Lafarge has been visionary and generous enough to support this effort, which could scale globally because it's a use case that we see over and over again. We're also working with Seneca Holdings, which is a group, First Nation group based in New York State region, to build our first commercial plant, which we plan to break ground on next year and be operating in 26. This would leverage funds ideally from the LPO's Tribal Loan Guarantee Program. And we'd be very thankful to secure that form of debt financing, which would be catalytic for this first of a kind plant. Seneca Holdings is the equity provider for this, and what we've done as a group to be ready to go to market is say, we've all started with these like really novel and new technologies, but as Maria alluded to, it's more than just the technologies. And as Todd said, we all believe our technologies are great, but what does it take to get a technology to market? It gets more into the sort of banal things like, well, sorry, all insurance providers out there for calling this banal, but being insurable, right? With these new technologies, being able to fully wrap our plants so that they're ready to produce fuels and have the performance guarantees that are necessary for the bankability. And so all of those types of, catalytic early stage capital for project finance, like the LPO has been providing, is absolutely essential. And some of the say, non-dilutive providers that Alex mentioned. I'm not in a position to mention some of ours just quite yet, but thank them in advance for all of their support so far. And I'll lastly just kind of give a shout out to some of our investors and customers at United Airlines as well, and Boom Supersonic, who we're excited to have just announced a purchase agreement with. So more to come on that. But I'll stop there and help us kind of reel in some more questions.
That was really great and hopefully very educational for folks. I think to wrap it in a bow, a lot of the policy incentives that came through and sort of these acronyms last year, IRA, bill, all of these great legislation were super critical and will help drive the green premium of these technologies down and help on the sort of supply side. And there's all of this important demand side pull that I think we also are getting at in terms of ensuring that, project bankability and insurability and all these other challenges are sort of thought of as well, and creating market shaping signals that will ensure that the private sector and sort of corporates can help, create demand for these things, which will really help drive the market as well. There are some very interesting questions coming through, and I think this next one will sort of wrap a couple of the questions folks have put in, in the answer. Let's transition to infrastructure. Obviously, how we move around these molecules and these electrons to serve the need of aircraft are super challenging because there's a whole, network involved with moving energy for aviation today. Would love for each of you to comment a little bit because I think you have a different perspective. Todd, I think you could talk a ton about, as we're scaling clean hydrogen, which in itself is sort of relatively nascent today, how do we think about the infrastructure needed to move hydrogen around? It's very leaky. There's not a lot of pipelines today that are able to do that, or if they are, they're sort of concentrated in areas like Texas where there's been a lot of hydrogen production in the past. So how do we think about that? And then maybe Jason and Alex also adding in thoughts on what challenges we should think about on the SAF side. I think one of the great things about alternative clean fuels is that they're drop-in ready and they could sort of be replace kerosene today. So how should people be thinking about how easy that drop-in is? I know there's blending walls, which maybe you can comment on, but how does the infrastructure in place today adequately or inadequately support that larger volume that you were mentioning getting at? So Todd, not to put you on the spot, but maybe you could start with hydrogen since it's also a very hot topic for the broader policy discourse.
Sure. So, well, the first thing, the good news is there's a tremendous investment in hydrogen right now. DOE is clearly all in. The Hydrogen Hub program, which is an $8 billion program, is going to establish hydrogen production across the US, right? That kind of investment is going to result in something. I suspect transportation-wise, at the very least, you're going to see, for example, a nationwide network of refueling stations for hydrogen fuel cell trucks. And if that's the least of the outcomes we get, I think that's awesome. But because there's going to be so much production, I think we'll have hydrogen available near airports. We have sort of a three-prong approach. Some cases will use a mobile refueler, or airports will use mobile refueling to get nearby production of hydrogen transported to the airport. In other cases, airports might end up piping it in and doing the liquefaction on site. An ideal case for us, I think, is airports that can electrolyze their own hydrogen. So it will require space, it will require renewable electricity or access to renewables. But it would also give airports a revenue stream that they don't have today. if they can get the investment necessary to install that the CapEx necessary. So we're preparing for all three of those scenarios, and I think it really depends on where you are. The question of who's paying for all this infrastructure is an open one, right? As I said previously, a federal credit program would be a good start to de-risk that environment for airports. So that to me is crucial. Airports are going to have to do what their customers want. And so if airlines are choosing to fly hydrogen aircraft, airports are going to not have a choice about making hydrogen available. But at least in the meantime, we can't sell aircraft without hydrogen being available to our customers. So we are deeply engaged in infrastructure as well. And I know that there are large aviation companies also engaged in hydrogen infrastructure. And then the last bit of good news is that the US has been using hydrogen safely for like more than 70 years, right? So it might be new to us in this virtual room today, but it's not new. And the legacy fossil fuel companies have a ton of experience managing hydrogen. We have standards bodies that have processes and procedures for managing hydrogen. We are engaged with several of them to work out the rules and rules of the road for safe handling at airports. So, and I will send it over to Jason.
All right, great, thank you. Yeah, so I mean, one of the great things about SAF, and continuing on with that, say, kerosene molecule, is that there are millions of miles of pipelines that serve trucking and aviation today, and if we can make a molecule identical to what's traveling through them today, that infrastructure is instantly leveraged, and that's going to be important to stand on the shoulders of this infrastructure that's been put in place over the last several decades. So how do we get there? How do we get to fuels you can literally drop in? And so there's a number of different pathways. There's not all ASTM annexes are able to go into the same mix necessarily out the gate. There may be some blending necessary. There may be various levels of without getting too technical, modifications being made. But once you're there, it's got to be the case that we can travel along the same conduits that typical fossil fuels make their ways through, and that isn't going to be the easiest from the onset. And so it might take some level of assistance to get to the level we need to be. We anticipate with our plans having complete upgrading and making a fuel that is ready to go. But there's also use cases where it may be the case that we'd like to incentivize existing refiners to buy our feedstocks at a slight premium so that our plants are bankable, where we can get into a final product without actually having to do the full refining ourselves, providing a synthetic crude that has a very low carbon intensity. So through going through a very comprehensive third-party life cycle analysis, right now we're just using the GREET method with the ISO 14040 and 14404 method. Perhaps we can drive down the overall carbon intensity of these refineries and not worry so much about our, say, pristine maybe volume of fuel, but how it plays into an overall decarbonization of a large system, so that the overall carbon intensity of all fuels goes down as we proliferate our plants. And that way the end product stays the same, but over time the feedstocks become lower carbon. And that's the vision we'd like to implement. The problem is along the value chain, you get a certain different amount for what you produce. And so the fine line is going to be, how do you finance projects with durable offtake at the right price? And so getting into the fine tuning of all these different business models we need to undertake to get these new fuels and feedstocks and aircraft to market is going to be, the detailed work that businesses are going to have to start doing together. We're already starting to do this with partners today, but we'll have to see a lot more creative collaboration to see the proliferation happen at the rate that we need it to. So I didn't want to get too in the weeds on this, but happy to answer any specific questions anybody would have.
Thanks, Jason. Alex, I don't know if you want to add anything. You're welcome to not, but if you do, go for it.
Yeah, I, if you don't mind, I'd be happy to. And then I know we got lots of questions to move to, but I think for infrastructure, I think number one for us is the key infrastructure is the SAF plants themselves, and so that's we have to build, a whole lot of SAF plants over the next 27 years to hit the 2050 goal, and all of that requires a huge amount of work and infrastructure there. So I would certainly start there, but hydrogen is a critical input to SAF, depending on the technology, different amounts, but access to low carbon hydrogen critical. We certainly have a common interest in having access to hydrogen. Same with renewable electricity and being able to move that around. That all of these things are critical to driving down the carbon intensity of our fuels. And so, in terms of hard infrastructure, in terms of the final fuel, we do talk about SAF as a drop-in fuel currently. So lots of advantages to being able to put that in the pipeline today, but it has to be blended first. It's a 50% blend wall for most of the SAF technologies that are being commercialized today. But and I always like to say it'd be a good problem to have a blend wall in the way we have a ethanol blend wall today of 10% ethanol in gasoline, where we're up against that. So 50% SAF would be over 10 billion gallons in the United States and over 50 billion gallons, globally, in terms of there. But being able to have 100% SAF, as Jason was alluding to, will really take costs out of the system. Even though we don't have a technical blend wall, it is something that makes things more complicated than making a ground transportation fuel. Having to blend that fuel, recertify that fuel, then put that into the pipeline does add costs into the system. So we're really excited about the 100% SAF efforts, and that is underway with task forces there, and it's been demonstrated, and numerous flights have been achieved in terms of 100% SAF. One United Airlines to Reagan National Airport in December 21. And so if we can get to 100% SAF, I think that's going to be critical to making things easier. You just need that much less steel in terms of tanks to blend with and all the rest, and help to drive costs down.
Awesome. Thanks, Alex. The infrastructure piece is really big here, so I'm glad we took time to cover that. Since we're down to the last 10 minutes, maybe we'll switch to not everybody having to answer, but maybe if you have thoughts about it, go for it. I think the last question that hopefully tackles some of the other things folks have been chiming in about is, you started alluding to the complexity of the ecosystem of the players involved in aviation. There's the, jet manufacturers, the fuel producers, there's airports, there's airlines, there's passengers, there's private aviation like jets, private jets, there's military and sort of public aviation as well, and they all kind of play a distinct role. So would love to kind of hear your thoughts on how key stakeholders are helping or not helping enough to get technologies off the ground, and challenges that you sort of see and being able to work collaboratively. I think Alex, was you who mentioned a lot of the need for those partnerships to enable the first of a kind and the first first before we get to nth number of facilities. And there are instruments like book and claim, which we don't have to go down the road of explaining that, but it's a way to enable, passengers and private corporations who, don't have access to the fuels themselves to be able to purchase SAF virtually, for example. And Todd, you've already mentioned a lot of the commitment from existing airlines of, procuring airplanes in the future. So would love to hear more about that ecosystem from you all. Where is it going really well, and where's the missing piece, and how do we activate that to expedite how fast we're seeing uptake in the market? Go for it, Todd.
I'm going to jump in just real quick because the one thing I would say, among the many things that I'd love to say, the one thing I really have to say is, if we have to, we can make it to market without another dollar of, federal R&D spending, right? But what we can't do is get to market without FAA certification. And so anything that Congress can do to staff up the FAA and increase particularly its hydrogen skilling is gonna really be the thing we need the most, right? The FAA certification office and the airport program office, they're great. Like, they are absolutely willing, but they are just burdened and under resourced, right? So if I don't say that before this thing ends, I would be remiss. Like, that's the number one goal. So
I would add one thing that is critical in my opinion right now is a very focused task force on what the carbon markets are going to do, because right now it's very confusing and the attributes are really making it complicated to talk through the whole value chain. And so we need to really decide as a global community what we're going to do with the carbon market, because we need one unified market.
Yeah, I can just add, I think Todd has mentioned FAA reauthorization. One of the things that we always joke about in the SAF community is SAF is the only thing that, business aviation, commercial aviation, OEMs, airports, they're all in agreement that we need SAF to help, decarbonize the industry. So we have a really strong stakeholder consensus on the need for SAF. Now, SAF and other reduction technologies like hydrogen, but certainly SAF is a key component there. And we have a great coalition that's been working on policies, the SAF tax credits, the grant programs that includes those stakeholders I've just mentioned, plus SAF producers, the existing renewable fuel industry, agriculture, unions, and others. So I think just continuing to broaden that stakeholder group, and having a consensus around the need for long-term SAF policy, to really help us have that investment signal will be critical.
Excellent. To continue lightning round, someone asked and would love your maybe 30-second version of what this should be. What do you think is most important for investors, especially large asset managers, to know about decarbonizing aviation and your technology in particular?
It's ready to go now, and you should invest in it.
Ours it's true zero emission. It's as zero emission as the renewable electricity that electrolyzes hydrogen can be.
Yeah, I would similar to Jason. Our motto is someday is now. So the alcohol to jet technology, is being commercialized today, is available today. We do not need to wait for the future, technologies. We certainly need those as well to hit the 2050 goal, but we need to start, building today. And in terms of the question of, will there be demand for SAF that an asset manager may have? We think the demand is not going to be the problem, and so even if we were to say hydrogen, you can have short haul and medium haul, and electric, you can have commuter. Long haul aviation is still 50% of aviation emissions, and SAF is currently the only solution for long haul aviation. So we're confident there's going to be a strong market for SAF. What those policy incentives will be, to be determined. But this market needs to happen, and is investable just on that long-term demand basis alone.
Great. I will try to answer one question quickly that's come up a couple of times on the energy demand of these new technologies. Of course, especially things like hydrogen, if produced via electrolyzers, will require a ton of energy, and there's options for doing that. You can do grid connected projects, and there's a very robust debate happening in the government right now, in Treasury, on how you account for emissions associated with connecting your electrolyzer to the grid. You can also have dedicated behind the meter, as they're called, projects that have renewables connected directly to the facility. So it is correct that there's great energy demand, especially as we're electrifying numerous parts of the economy that can be electrified. And that's why there's a ton of important work happening on the power sector on bringing more renewable and clean generation online, building transmission lines to get more of those electrons to the places where they're needed. And so that is a whole category of work that I'm glad other people are thinking about. And hopefully, you know, if not the folks on the panel, but others are definitely working to advance those. The other quick tech-related questions, which hopefully you can do lightning round of, Todd, there was a lot of interest on some of the technology aspects of ZeroAvia's technology. Do you use batteries? How is hydrogen stored on the plane? Liquid, gaseous? Tell us a little bit about that. And for the staff folks, there's a lot of interest in any challenges with feedstocks, how to think about limitations to feedstocks, and how in the future, you know, we can transition to other feedstocks as a way to circumvent that. So whoever wants to start, but those are some tech specific things that would be great for folks to hear about.
Cool. Well, just quickly, I'll say our first 9 to 19 seat aircraft is going to be powered by gaseous hydrogen, compressed. And then from there forward, we're going with liquid. So there is a lot of energy used in maintaining cryogenic hydrogen, but we're accounting for all that. And there, hydrogen. If you were going to anthropomorphize hydrogen, you would say, like, if it has one desire, its desire is to escape. But we're containing it. So far, we haven't really encountered too many obstacles. We have ways to sort of take the boil off and use it elsewhere. So we're good.
I would say, we're energy intensive is correct. That's a great call out, whoever made that. And we're talking about just transporting energy in liquid form here. And that's why we've just focused on energy conversion as really the most, our most intense focus, and carbon efficiency. So we solve for those things to live within the bounds of the energy intensity of this overall endeavor.
Yeah, and on feedstocks, I would just, I think I mentioned on my, opening that there's a lot of existing ethanol out there, today, and so, I think the question is really, where do we, think about putting our biofuel resource over time, and pivoting that to those hard to decarbonize, applications. And aviation is the number one hard to decarbonize liquid fuel user, I would argue. But beyond those existing feedstocks, I mean, ethanol, as I mentioned, you can make a lot of, can make ethanol out of a lot of things. And, there's been a lot of studies on the availability of biomass, and it being, much more significant, sustainable availability of biomass than we may think. But again, it's also, where do you put that biomass in a low carbon economy? And I think aviation should be prioritized. But even accepting that there are feedstock limitations, and we don't think they're as severe as some might argue, we have technologies to, as Jason's described, and we can do it with alcohol to jet as well. We have, limitless feedstock in terms of captured carbon, whether that be point source carbon or ultimately direct air caption carbon, combined with renewable energy and green hydrogen to make a drop-in liquid hydrocarbon.
Well, I think Sarah came on to tell us we're at time. Thank you so much to our panelists. This was very interesting, and there was a ton of good questions to the audience that we're so sorry we couldn't get to. Hopefully this at least opened your mind to the interesting world of aviation technologies and decarbonization pathways. So thanks, Sarah, for having us. And I think someone asked about seeing this, later, and I believe it'll be on YouTube for anybody interested, but maybe you can comment on that.
Yeah, this was recorded. It'll be available on demand using the same link that you joined with today, and we will also post it on a link on our website and on our YouTube page, so you should be able to find it in lots of places. Thank you all for joining and staying the whole hour. It sounds like we're going to need a 201 level briefing, a follow-up to this, since there was so much interest. So maybe be on the lookout for that, and hope to see you all on future events. We've actually got one on clean cars and trucks next week at the same time, so feel free to tune in then. And thank you again to our panelists. You are all awesome, and we'll be back for the next installment, it sounds like. Thank you all.
Thank you, everybody. Great.